Hey everybody, thank you for joining us for a deep dive into the AWS Cloud Development Kit. My name is Jason Fulgham. I'm the development manager for the AWS CDK.
Hey guys, I'm Elad. I'm the principal engineer for the CDK. Thanks so much for coming. It's awesome to see everybody here.
So there's a bunch of great resources online about some of the basics of the CDK and some introductory material. Last year, Elad and I came to reInvent, and during developer preview, we showed off the TypeScript experience for the CDK. Earlier this year, after we GA'd support for Python, we did a fun online tech talk. So you can watch those, you can learn some of the basics. This session is not going to be the basics, though. This is going to be a more advanced session. We're going to get pretty deep, or we're going to cover a lot of deeper topics. All of these topics have a lot more meat to them, so I hope that you're inspired to go and explore more. Don't worry if you miss stuff. We're going to leave some little breadcrumbs for you and point out some resources where you can go and learn more. So I hope you guys enjoy it. Plan for the next hour is we're going to briefly cover some CDK concepts just to make sure we're all on the same page. Elad is going to give us basically a speed run through CDK concepts. Then we're going to set up some context for the demo that we're going to be building. We're going to be revising this fictional Walters Co. company that we've used in previous demos. And we're really going to spend the bulk of our session together live coding in 2 different parts. And we'll wrap up. We'll tell you about some more fun stuff going on this week, some places you can go to learn more about the CDK this week and online, and just how you can keep going deeper into the CDK.
OK, I'm curious. Who here heard about the CDK? OK, that's good. Who used the CDK? Awesome. Who contributed code or issues or submitted PRs to the CDK repo? Yeah, thank you. Yeah, super. The volume. I don't have any control over the volume. I can try to speak up a little bit. Yeah, I mean, it's great. Like last year, I think when we were here, there were 5 people who heard about the CDK in our session. And so this is really moving and exciting for us. As Jason said, we're going to do a deep dive or advanced session this time. There's so much really awesome content out there for getting started. And so if you haven't tried the CDK yet, at the end, we're going to provide some links for you to follow. So in this part, we're just going to do a quick rundown on what the CDK is in concept, but hopefully most of you know it already. So the CDK is a software development framework for defining cloud infrastructure using familiar programming languages. And when we use familiar programming languages, we enable us, the developers, to harness the full power of programming languages and object-oriented design in order to model our infrastructure and define the infrastructure logic, same way we do for application development. And we also allow ourselves to use the same tools, techniques, and workflows to create an end-to-end process for defining cloud applications, both from the infrastructure perspective and the application development. And we're seeing a lot of our customers starting to do that and really enjoying this holistic view. We realize that in order to make that work, we need the CDK to be available in multiple programming languages. And so today's CDK is available in JavaScript, TypeScript, Python, .NET, and Java, and more languages are coming up, of course. So this is how it works. You write your code in one of the supported programming languages. CDK applications are structured as a tree of constructs. At the root of the tree, there's a construct that represents your application, and then there are constructs that represent stacks, constructs that represent abstract ideas, and eventually, there are constructs that represent actual cloud resources like S3 buckets or Lambda functions. And then all of those things form a tree. And when you use the CDK CLI to synthesize your application, you get CloudFormation templates and other deployment artifacts. And then you hand it over to CloudFormation. So you get the benefits of using the CloudFormation engine with its transactionality and rollback capabilities, and its declarative approach for desired state configuration, while still enjoying the power of general-purpose programming languages and object-oriented primitives in design. The CDK contains 3 main components: the core framework, the construct library, and the CDK CLI. The core framework basically has the basic building blocks, the foundation, the app, the construct, the stack, those base classes. And the AWS Construct Library is a rich class library of constructs that enable you to use AWS through this rich object-oriented API. So we have constructs for many AWS services, and we're building more and more of them. The construct library also includes low-level constructs that represent all of the CloudFormation resource specifications. So any CloudFormation resource that's available is available as a strong type class in the construct library. But we also have higher level classes that represent all of those resources. The CLI is a command line interface for interacting with CDK applications throughout the development lifecycle. It allows you to synthesize apps, look at the output of the template, diff against the current state, deploy your applications, et cetera. OK, so Jason will walk us through the demo scenario, and then we're going to start coding, hopefully, as soon as possible.
So just a minute or two on the context of the demo scenario we're going to be working in today. Elad and I are, again, portraying developers at a fictional company called Walters Co. And Elad and I work on this central infrastructure engineering team. So essentially, we work with all our application development teams, and we help them be successful and use the right patterns and practices for their infrastructure. I'm sure that all of you have seen the AWS Service Health Dashboard before. Obviously, we do this to give customers and partners transparency into how our systems are operating. And we want to do the same thing at Walters Co. We have partners and we have customers that rely on our APIs. So we want to provide this public-facing health dashboard to be transparent about how our systems are operating. So on this central infrastructure team, Elad and I run this service that monitors the health of all the different APIs in our company. So the application development teams will come to us, and they'll provision a resource in this internal system, this internal health monitoring system that we run. And that system will do health checks on their APIs, and it will also publish the status out to this public status dashboard. So this works well, but it does mean that the application teams have this kind of manual step that they have to go through. Once they launch a new API or once they expand to a new region, they have to remember to come and talk to us and enable their new region and their new API to be monitored. So that's working OK, but we'd really like for it to be automated and kind of unified in their provisioning. So we're going to talk in a little bit about how we can use some extensibility features in CloudFormation to do that. And particularly in the first demo, we're going to dive in and build a construct library, show off some custom resource providers, talk a little bit about how to structure your stacks, and also a little bit about some construct design patterns. In the second part of the demo, we're going to follow up and keep building on that example. And we're going to show you how we can take that TypeScript construct library and expose it for Java, Python, and C# developers to use as well. We'll talk about some of the tools and techniques we use to build the AWS CDK and the construct library itself, how we do multi-language publishing, and a little bit about environment-aware applications. So I will turn things over to Elad, and we'll get started with the fun part, building some code.
Yeah. OK. So like Jason said, our company has a few service teams. They all use CDK to define their infrastructure. And what we want to do is we want to enable them to basically use constructs in order to define this resource called health monitor, right? Like it's this internal system that we have that maintains these monitors and shows this status dashboard. It's a pretty common scenario. I mean, many companies have these internal systems. And what we wanted to show in this session is how you can integrate these internal systems to the same workflow that you have for the rest of your architecture. And so the first thing we want to do when we design constructs is we call it working backwards. It's actually something we use at Amazon a lot for anywhere in the company, working backwards from the customer experience, trying to first think how the customer approaches this problem before thinking about the implementation details or the constraints, trying to think about the mental model of the user. And so if I'm a user and I want to define a health monitor in my stack, then I'd probably do something like this, right? Like I would say, new Walters health monitor, and then I would specify the app name, what region I am at, right? Like we saw that this health monitor has multiple regions for each app, so we should be able to like show that matrix. And then the endpoint that I want the health monitor to monitor. And I can create multiple monitors. Maybe I have multiple endpoints in my service. And so this feels like a natural and intuitive API for our developers. Let's start by writing this API, and then we see how we actually implement it, OK? OK. So I'm kicking off VS Code. We have an empty project here. It has a CDK app with a test stack. This project is actually a library. We're not actually vending an app. We want to vend a construct. We want to vend a library for our users. And so this app is just defined as an integration test. It's kind of like this local thing that I'm using as the developer of this library to test that my construct works, but I'm not actually going to export that outside of the library. OK, I'll prove it that it's an empty thing. CDK synth should show me an empty template because our stack is empty. There's no resources. And so first thing I want to do is I want to create my construct. I want to define it under the lib directory. And we'll call it healthmonitor.ts. And I hope most of you know that construct and the CDK are basically classes that extend the construct base class. It's a very simple programming model. Intentionally, we wanted to make it really easy for anyone to create their own constructs, both for sharing and reuse, but also for just organizing your application into modules, into subsystems. And so constructs are kind of like classes, right? So let's define the health monitor construct and extend the construct base class. And now let's define the constructor. And so constructs all have the same initializer signature. They always receive the scope and an identifier, which basically creates a namespace. And so constructs have this really powerful capability of creating an isolated namespace within your configuration tree or within your application. So we'll see that in a second. Basically, scope is the first parameter, ID is the second parameter, and in most cases, we also have a bunch of properties that we pass into the construct. And so in our case, the properties, we already showed them earlier. It's going to be app, right, region, and endpoint. Pretty straightforward. And you know what? Region is actually something that I can do a little better with, because when I define this construct within the context of some stack, I actually know the region the stack's going to go to. And so let's make region optional, so we can like basically not specify it if we intend to use the same region. OK, so let's see how I'm going to use this. I hope that that's going to look like what I expected. So I'm going to do health monitor, and let's do AWS home, and then app would be AWS homepage, and endpoint is going to be with hope that this is going to be green today. Just today, at least today. OK, this looks nice. This is kind of like what I would expect as a developer. If I synthesize this, it's still empty, right? Because this construct doesn't have any resources in it. It's just this idea now, right, that I'm expressing in my code. And so next thing I want to do is I want to define resources within this construct. And normally I'd use AWS resources, like S3 buckets or Lambda functions or SNS topics or other constructs that eventually use resources. But in our case, we don't have an AWS resource that represent our health monitor, right? Like this is kind of like this internal resource that I have in my health system. And so in order to basically allow CloudFormation to provision resources that are not defined in the CloudFormation specification, I need to create custom resources. And CloudFormation has recently launched the CloudFormation registry, which basically allows you to register custom resources formally and basically use them in the template. But it's exactly the same thing. It's exactly the same idea. The only difference is that now I'm going to actually define the custom resource within my CDK application. So I don't have to go and publish it anywhere. It's just bundled into my application. And then when someone uses my library, they just get the resource out of the box from that library. There are pros and cons to both approaches, and you can use both. OK, so CloudFormation custom resources, I hope that most of you are familiar with them. They're actually incredibly powerful, and you can do awesome things with them. CDK has some nice framework for building custom resources, and we're going to use that, and I'll show you how easy it is to create them. Basically, they behave like regular resources. They're plugged into the template like any other resource. I see this little yellow thing here. And then when CloudFormation sees this resource as part of the provisioning process and makes a decision about what kind of action needs to happen to that resource, whether it's creating the resource or updating it or deleting it, it'll delegate this activity to the custom resource provider. And so that's basically an open-ended thing. You can do whatever you want there as a reaction to that event. And in our case, what we're going to do is we're just going to send some HTTP requests to our REST API as a result of each one of those requests. OK, let's go ahead and write that down. I'll start by importing a bunch of modules. So we're going to import the CloudFormation module. We're going to import the Lambda module, which is how I'm implementing, how I provide my provider implementation. And I'm going to also import the CDK's custom resources module, which is the module that contains the high-level abstraction for creating providers. Cool. So first thing I want to do, I'll do it bottom up. Okay, I'll start with actually defining the resource in my template, and then we'll see what the API, what the ID tells me to do. So I'm going to do new CFN custom resource. We'll call it resource. And if I look at the API here, I can specify properties, provider. This is like who's going to actually implement this. Removal policy is basically how CloudFormation deals with it when it's removed. Does it leave it as an orphan? Does it actually delete it? And resource type is like the string that basically allows me to differentiate between custom resources within the same template. It's actually optional. I don't have to specify resource type. It's a good practice usually to if you have multiple types of custom resources, it gives you a nice UI cues. So let's just do this Walter's Health Monitor. And properties, I basically want to propagate those properties that I received from the user, right? So I want app to map to app, and endpoint to map to endpoint. And region actually needs to either map to region, or give me the region from the stack. So I'm going to go up to the stack and get the region. And the CDK has this static method called stack.of, where you can basically find the stack from anywhere you want in the tree. So basically, give me the stack that this is defined in. And so basically, stack of this dot region is going to give me the region. And then the last thing I need is the provider. And so let's see. You can implement a provider by listening to raw CloudFormation events through SNS or Lambda, or you can use this CDK's custom resource provider framework. And as I said, we're going to use a provider framework. Custom resources are not too hard to implement, even if you use the raw CloudFormation events. There are some pitfalls. I don't know if any of you had experience trying to implement custom resources, getting your stack stuck for 2 hours because you forgot to catch some exception and forgot to return the responses. And so like the framework makes it really easy to handle. You don't have to care about those things. And the framework also has some pretty nifty feature I'll show you in a second. OK, so let's just do this. Provider. And so now I'm going to need to create the provider. And I'm going to use CR provider. OK, so this is going to be my provider. And if I look at the API here, the main method, the main API, the main property that I need to specify is the onEvent handler. That's a required property. It's a Lambda function that implements the event handler for my resource. I also have the ability to implement another handler called isCompleteHandler. And we're not going to do this here, but the custom resource provider framework has this support for asynchronous custom resources. And sometimes it's really, really useful. Like in many cases, it's not needed, but sometimes it takes some time for resources to actually stabilize or to be eventually consistent. And you really don't want a busy wait inside your Lambda function. It's limited to 15 minutes and costs you money. And so this method is basically another Lambda function that you provide that basically returns true or false if the resource is ready. And as long as it's not ready, there's a retry policy. It'll call you back based on the policy that you define, and only finish the operation when the resource is ready. And it's useful for the use cases that it's needed. It's very useful. But we're not going to need this here. So I'm just going to basically provide a Lambda function here. OK, new Lambda function, handler. And I'm going to use a handler that I already have here prepared. I don't want to spend our time sending HTTP requests. That's a different session. And so that's a Python handler. It has a main method called onEvent. And we're going to go through this code in a second while this is deploying. So I'm just going to basically, on event. The runtime is Python. And the code comes from this asset. Asset is this local file that's bundled into my project, and I can publish it as part of my library handler, right? And I'm also going to specify the timeout, so we're not going to have any problems with it. The default timeout, I think, is 3 seconds or something. OK. So this is basically all I need, right? Like I now have my provider defined. We're going to look at it in a second. Let me just deploy this, and then we're going to check out the provider. Did I forget anything? No.
Not this time.
OK, let's get this going. And in the meantime, let's take a look at this for a second. So the framework calls on event with the event and the context, and then we dispatch to one of the 3 methods, create, update, delete. You can do that. You don't have to do that, depending on your implementation. And so now we basically just call into these 3 methods. And it's very straightforward. It's basically just mapping the on create to post, on update to put, and on delete to delete, which is probably the most expected thing to do. And we were actually thinking of providing a custom resource, high-level custom resource abstraction that's like automatically mapped to REST APIs, right? Like that's a common use case. But even without that, it's pretty easy to implement. The only interesting thing that may be worth mentioning here is this concept of a physical resource ID. You can see that when I create a monitor, I basically get a response that has a monitor ID. So it's basically this opaque ID that represents a specific instance of the monitor in the monitoring system. And by returning it under the physical resource ID property attribute, I basically store this information inside the CloudFormation database. And so next time when CloudFormation updates or delete the same resource, it'll give me the ID under the event, so I can basically send it over to this REST API and perform the updates. Most AWS resources have physical resource IDs, right? In many cases, they're also, users can control them, right? Like bucket name is a physical resource ID. But in many systems, they're not in control of the user. They're just like these opaque tokens that you need to like piggyback. OK, so this is finished. Let's see if we have, yay, AWS homepage is green. This is good. US East 1 is basically derived from my environment. That's the default environment that I'm set up. So this is nice. I've got my little resource ready. But there's a problem here. And in order to demonstrate this problem, let me try and, I don't know if you guys noticed it. I'm going to create another monitor. OK, let's create a monitor for Amazon Home. And it's completely legitimate. I can create a few of those. Amazon. And we're past Black Friday, so that could be red. It's OK. And so now I've created this other monitor, and I wanted to show you some pretty cool tool that we released a couple weeks ago as developer preview. It's a very initial version of this tool. We have some really fun plans for it. It's called AWS CDK Explorer. And it's part of the VS Code extension, AWS VS Code extension. If I synthesize my stack and then go to this little pane here, I can visualize the tree, my construct tree. I can basically see the tree of my construct. So I can see the app here, and I can see the stack that I have here. This is the name of my stack. And then you can see that I have AWS Home and Amazon Home. And there's another construct here that was created by the system, which we should probably like hide somehow. But the interesting thing is when I start to dive deeper into this, this looks a little weird. Because now I have basically 2 resources. And each one of those resources have basically the custom resource defined in it. But it also has the entire provider defined inside the resource. And the providers are, they could go a little, they can have some resources that support them. If you use the asynchronous provider, you're also going to get a step functions there. And so it doesn't really make sense to maintain a single instance of it, to maintain a one-to-one relationship between a resource instance and a provider. I actually want to have a single provider for all those resources. There's no need for me to actually maintain one-to-one relationship. I need one-to-many. And so what we want to do is we want to get these provider resources and actually define them at the scope of my stack and not at the scope of my resource. And CDK makes it really easy to do that. So we're going to implement this singleton pattern, right? Like it's basically I want this thing to only be created once and reused if it's already there, right? So let's dive into this code, and I'll show you how you can do that pretty easily. So first thing I want to do, I want to create a construct. That's probably it's true for everything in the CDK. Health monitor provider. Sorry. And the goal of this construct is to basically, package all the resources that are related to the provider into a single entity, to a single unit. Same as before, I have scope and ID. And I'm just going to do a quick factor by taking this chunk, which contains the Lambda function and the provider, and the Lambda function has a role in it and other things. So it's basically a group of resources. I'm just going to put that here and make that available outside provider. Oh, what's going on with my typing today? I'm too excited. Provider. Okay, good. So basically just expose it outside my class. And now I'm going to do my provider equals health monitor provider, this provider. And then here I need to basically use the internal provider because the external thing is just a construct. Okay, let's see what CDK Explorer tells us now. Okay, still have two resources here. Still have two providers. Now they're nicely packaged together, so we can see this refactor happening in our tree. It's not what I want, right? Like I want this provider to be defined at the stack level. And so the way I do it is basically, let's get a handle to the stack. We know how to do that already. And I'm just going to define it here, right? And now, since I'm defining it at the stack level outside my scope, then I need a unique identifier. Because one of the nice things about CDK constructs is that they give you an isolated namespace. So you can just provide those IDs, and you control all of the IDs in the namespace. But what happened if someone would define a construct at the stack scope that has the provider ID? We're going to get a collision. And so if you define things outside your scope, it's very important to make sure that those things are uniquely identified so they're not colliding with other things, especially if you're vending a construct library for other teams, right? So let's just do something stupid like health monitor, Walters, whatever, something like that, and see what happens. Let's synthesize this. Okay, I got an error here. There's already a construct with this name, right? Because I've instantiated it twice, right? Every time I instantiate my resource, it also instantiates the provider at the stack level. So now all I need to do is basically just do this conditionally, right? Like reuse the one that's already there if it's there, or instantiate a new one. And so the pattern is very, very straightforward. We're just going to hoist this ID so it's easier to reference because we're going to need to reference it twice. And then I'm going to do stack.node. .node in every construct is basically giving you access to the construct tree. So it's not about the resource or the AWS aspect of the construct. It's about how the construct is operating within this tree. There's some really good and useful stuff there if you're interested in exploring more. One of the methods there is try find child. So it basically tries to find a child based on an ID and then returns null if it doesn't. And so all we need to do is basically say try find child ID or new health monitor provider. And the only thing I need to add here is a downcast, right? Because try find child returns in I construct, and I know that this guy is actually a health monitor provider. And so this is basically how singleton patterns can be implemented in the CDK. Last thing I need to do is I'm going to need to change this resource ID, and it's a question for the audience at the end. Come tell us why. See if you know why. Okay, so this looks okay. It's now synthesizing. Before I'm deploying this, there's just one last thing I want to do. because we've been talking, and we're vending this library for our service teams, and we're going to vend this construct. But this construct has probably 10 or 15 resources in it or something like that. And it's going to have more if I'm asynchronous or I'm doing something else. And our customers are going to integrate that into their stacks. And as you know, CloudFormation has a limit of 200 resources in each one of those stacks. And so taking up 10 or 15 resources of 200 is actually a pretty expensive thing. And so what I want to do, ideally, is I want to take all of this provider stuff and package it as a nested stack. Nested stack is one resource that represents an entire stack that's deployed by CloudFormation separately, and it behaves as a regular resource. And so let me show you how to do that with the CDK. That's all. So all you have to do is just take a construct, turn it into a nested stack, and the CDK is actually doing quite a lot of heavy lifting to make that work seamlessly. You can reference things across nested stack boundaries, and it'll automatically create parameters and outputs. You can create dependencies across nested stack boundaries, and it'll automatically find the right place to create this dependency between the two things. And so there's a lot of heavy lifting behind this little nested stack thing. OK, let's just deploy this and do a little recap, and hopefully that'll finish before we end the recap. OK. So we talked about working backwards from the API. It was just a little glimpse into the design process that we do for constructs. We're seeing more and more that this whole design discipline is something that DevOps engineers and people who've been doing infrastructure, they're learning how to do that. And we're learning how to do that all the time. We've got some resources. We're actually planning to publish the AWS Construct Library design guidelines document, which we use for the AWS Construct Library. And so we hope that would be a good reference for design principles related to designing these class libraries and APIs. We talked about custom resources and how powerful they are, the resource provider framework. We talked about CloudFormation Registry as an alternative way to publish custom resources. But eventually, the idea is that you package it as a construct. And so a construct is a first-class citizen in the CDK. And there's no difference between a construct that you wrote or a construct that we wrote that came from the construct library. And so I think this is one of the most important things to take away, right? Constructs are all created equal. I showed you how to do singleton pattern. You can do it at any scope. You can do it at the app scope or at the environment scope if you want. And we briefly showed you how to do nested stacks. And obviously, there are more details to it if you're interested in the documentation. And CDK Explorer for VS Code. We'd love to know what you guys think about it and what features you'd like to see there. We're thinking about allowing you to deploy from that tree and diff from that tree and do some cool stuff that basically not leave your IDE so you can interact with your CDK application very naturally. Let's see if this is, yep. OK, ta-da. Now Amazon's green too. Great. Now Jason, let's go. Let's see how to do some really cool stuff.
So in the first part of this demo, we got this cool TypeScript CDK construct library. We can give that out to all the teams at Walters Code that are building their CDK apps in TypeScript, and they can really easily integrate into that health monitoring system. But we haven't really solved the problem for our developers that are using Java, Python, and .NET. So in this next part of the demo, we're going to talk about how we do that for the construct library in the CDK itself, how we provide that multi-language experience that's always in sync with the different languages. And we're going to show you how you can do that for your own construct libraries, too. So a quick history on where we're at with multi-language support in the CDK and why we think this is so important. Earlier this year, we GA'd support for TypeScript, JavaScript, and Python. And then last week, we were super excited to announce GA support for Java and C# as well. So as a CDK developer now, you have your choice of 5 languages that you can use in production with that GA stability, that backwards compatibility guarantee. And we're really excited about that, to have those 5 languages. But we're not satisfied. We want to keep adding more languages. There's a few that we're already playing with. We would love to hear from all of you what languages you want to see next for the CDK. So please engage us on GitHub. We'd love to hear the feedback. The reason why we think this is so important to have this multi-language experience is that we see this really strong advantage that developers get when they can take care of their application code and their infrastructure code using the same programming language, the same package management tools, the same development tools. They get this nice kind of unified development process where everything just fits together really seamlessly. So we're really excited about that, and I think that's one of the things we've been hearing so much customer excitement about. So to do that, we had to come up with a new way to provide that experience in all these languages. We knew that we wanted to provide this multi-language idiomatic experience, and we also knew that there was no way we could just brute force it for all these languages and keep them all in sync and keep the features consistent. So we invented this new project, created this new project called JSII. It stands for the JavaScript Interoperability Interface. And essentially what JSII does is we take our TypeScript code base and we use the JSII tools to produce this metadata that allows us to build these bindings in our target languages on top. So when you're using one of these target languages, you have the Construct Library interface exposed in Java or Python or .NET. You get to interact with that interface. But what's happening underneath is you're using the Java code and it's proxying everything over the JSII protocol into a node process that's running all our JavaScript code from our TypeScript code base. So JSII is open source. So you can find JSII in GitHub, of course. You're welcome to use JSII. We haven't really talked about it a whole lot, so we're excited to come and talk about it a little bit more today. You're welcome to use it for your construct libraries or even just any other TypeScript libraries. The README will walk you through how to set up JSII and some of the constraints you should be aware of and some of the configuration options. But let's jump into VS Code and let's see if we can turn JSII on for our TypeScript library that we just built. So first thing, we obviously need to get the JSII tools into our workspace. So I'm just going to install these developer dependencies for JSII and JSII PackMac. We'll talk about PackMac a little bit more in a minute. That's what actually does the generation and creates the packages for us. All right, so we've got JSII, we've got our tools in here. Let's open up our package JSON. And right now we're just building our code with TypeScript. So we want to swap that out and build with JSII instead. So JSII is still going to run the TypeScript compiler for us. It's still going to translate our TypeScript code into JavaScript. But it's also going to produce a lot of metadata that we'll see in a minute. And then we added this new command to run JSII PackMac that we'll get to in a minute. So we've got our package set up to run JSII, but we haven't actually supplied any configuration yet. So let's plug this in and take a look. So we've added just a little bit more metadata to our package JSON that JSII needs in order to run. The most important section is, of course, the JSII section. And this is going to define where we want to output all the code we're generating, which languages, which target languages we want to generate for. And then for each of those target languages, there are some configuration options, how we want to set up the namespaces and stuff like that. All right, so we've added JSII, we've set up our build, and we've got our configuration in here. The last thing I'm going to do is get rid of our tsconfig file. So when we run JSII, it has some very specific TypeScript configuration that it relies on. So we're just going to move our tsconfig file out of the way, and we're going to let JSII create that tsconfig file for us. So JSII is running. It looks like it's updated some of our peer dependencies. We've got a new TypeScript config file, but we've got some errors. We don't have our JSII metadata yet. So let's take a look at what's going on here. So in our health monitor class here, it looks like JSII is complaining about our health monitor props. It says the property app and data type health monitor props must be read-only since the data is passed by value. So this is actually a really important point. JSII relies on some constraints on the TypeScript language and how you write your TypeScript code. So if you want to start using JSII, it's really better to start from the beginning of your project so that you can find these constraints as you hit them quickly. It's going to be easier, obviously, than trying to take a large TypeScript code base and removing when you hit those constraints. So for example, generics is something that we don't support right now in JSII. So if you're using that in your TypeScript code base, we just don't have that feature yet in order to map that into all the target languages. So this error specifically is complaining because we've got this interface, but our properties in here aren't read-only. So that's obviously an easy one for us to fix. Let's talk for a minute about why we have to do that, though. So it's important to remember that architecture of JSAI that we talked about a minute ago. You've got your target languages sitting on top that you're interfacing directly with, and then the communication goes over the JSAI protocol into that node process underneath. So that node process is really going to be what's running our infrastructure logic for us. And as we pass these health monitor props, as we create these in our Java or Python or .NET code, they're going to be passed by value over that JSAI protocol. So there's no way for the node process underneath to update the values back in the target language. So JSAI wants us to explicitly declare these as read-only, so we get that, that compiler checking to make sure that we don't ever try to change these values. OK, so let's see if we can run JSAI again. And with any luck, we should have this new .jsai file that's produced all this metadata that basically has analyzed our code base, and it's going to be everything we need to generate those bindings in the target languages. So sure enough, here's our .jsai file. There's a bunch of information on our dependencies. There's a lot of information on the types in our code base. And obviously, we're going to use that information to build that bridge in our target languages. So now that we've got our JSAI metadata, we're going to run our package command. So this is invoking JSI packmac. Packmac stands for package maker because that's the output that it's creating. It's going to create these ready-to-use packages for all the package managers and the languages we're supporting. So it looks like our code is generated. Let's check out this dist directory. So this is everything that we've just generated here. For Python, we've got a wheel file that we could take and deploy to PyPI. For our JavaScript code, we've got a TGZ we can upload to NPM. .NET, we've got NuGet packages, of course. And then as much as I love Java, of course, Java always has to be the most verbose. We've got about a few dozen Maven artifacts ready to use. So let's see if we can take some of those Maven artifacts now that really build this bridge to our TypeScript Construct Library and see if we can use those in a Java app. So over in IntelliJ, I've got this new Java CDK application that I'm building. Super simple. We've got just one stack in the application right now. And inside this stack, we've got a single function and a REST API that's running it. So what we want to do is add this health monitor into this stack and see if we can get our Java CDK project to show up on that status dashboard and use that construct library seamlessly from Java. So the first thing we need to do is, of course, pull in that dependency for those Maven libraries that we just made. And as part of producing those, JSI packmac builds those Maven artifacts. They're already installed locally in our Maven local repository. So it's very easy for us to just grab these. co.walters.co. And this is our health monitor. And the version we declared in our TypeScript codebase was 0.1.0. And we saved that. And sure enough, under our dependencies, maybe too small for you all to see, but we've got this health monitor jar showing up. And we can drill in here, and just like we expect to see, we've got this health monitor class that maps that same construct we just built in TypeScript. And we've also got this health monitor props interface that declares those three properties we just talked about a minute ago. So we've got this code for this Java bridge into our TypeScript construct library. We've got this loaded into our Java application. Let's see how we instantiate this health monitor object in Java. So this is our co.walters health monitor project here, or construct. And as we map the TypeScript code base into these different languages, we try to make them fit the style of those languages. So the TypeScript code base, the interface is going to change just a little bit as we map it to different languages. So one really common pattern is the properties that we created to pass into our construct to initialize it. As we map those to Python and to .NET, we have named arguments that we can use for those. We don't have that feature in Java, so we use a builder pattern instead to get something similar. Just like we talked about before, whenever you create a construct, we're going to specify the enclosing scope for that construct. I'm just going to specify the stack that we're working in. So the stack is going to be the enclosing scope. It's going to contain this health monitor construct. And we'll give this an ID. And at this point, we're specifying those construct-specific properties. So the endpoint that we want to monitor is, of course, just our API that we just defined on the previous line. So we'll grab our URL. And this app parameter is the display string that we're going to see on our health dashboard. So let's call this my new Java CDK service. And last but not least, of course, we have to call build to actually create the object. So that's looking pretty good. We got this construct used in our Java code. This is ready to deploy, but before we do, I want to talk just for a minute about environment-aware applications in the CDK. So if we go back and look at our application, this is obviously a super simple application. We've just got this one stack, and application is what we would call environment agnostic. An environment with the CDK consists of the account and region ID, and it tells you where your infrastructure is going to run. So environment equals account plus region. Right now, none of that information is encoded into our CDK application, so it's environment agnostic. It knows nothing about the environment. This is super convenient when you're in development. It means you can pick this app up and you can launch it in any account, in any region. But as your application, as your system gets more complicated, as you have stacks in multiple accounts and multiple regions, you're going to want to start encoding that information into your CDK application. And that's really easy to do with the environment support in the CDK. So the way that you specify the environment information as you create your stacks is by specifying stack properties. So we're going to go specify that in a minute, but right now we are going to just specify the environment and just pass that in directly. If we wanted to specify tag information or descriptions for our stack, then we just go ahead and create the stack properties here. But let's, just for this demo, we'll pass in this CDK environment object. Again, we're in Java. We're going to use a builder pattern. And we can specify our region or our account. We're just going to go ahead and specify that this stack should always run in US East 1. So that's the interface that we would like for this new stack. And that gives us a really easy way to instantiate this stack in multiple regions. So maybe we want a backup stack for redundancy. And we'll set this one up to launch in US West 2. So let's go into this constructor and see if we can make our code happy again. We want to take in this environment parameter. And then we specify the environment as part of the stack properties, and we always pass those stack properties up to the parent stack, and that's how the stack is going to get that environment information. So stack props, and we'll just plug in our environment here, and that's it. It looks like our app code is happy again. So let's go ahead and start our deployment. We're going to compile our Java code because we made changes, of course. And then we're going to run the CDK CLI to deploy this. And we specified star. You might have seen that on the command line because we now have multiple stacks and we want to deploy all the stacks. So let's give this a minute. And then when we come back, hopefully we'll look at the status dashboard that we used earlier. And we'll see our new Java service is showing up not only for US East 1, but also in US West 2. While this is deploying, I want to show you one more neat tool that we use to publish our CDK libraries. This is another open source project. This one is called DelivLib. DelivLib stands for Deliver Libraries, and it's a CDK construct library that helps you set up and manage these continuous delivery pipelines using AWS Code Pipeline. And it lets you deliver these code libraries in multiple languages. So this is a perfect tool for delivering construct libraries. You can run your build with JSI PackMac, and then you can use DelivLib in your publishing stage to publish to all those different package managers for all the languages that we built. So this is another good one to check out. This is an experimental project, so the APIs are likely to change at some point. But this is, again, what we're using for production with the CDK for the construct library and the CDK framework. When you stamp out these pipelines with AWS Code Pipeline, with DelivLib, you're going to get a pipeline that looks like this structure, where we've got our source stage pulling data from either GitHub or code commit. And then we've got a build stage using code build that's going to obviously compile our package. With our construct libraries, we're going to use JSI PacMac to produce all those different bindings. Then test stage, of course, we're going to run our test. And then the really cool part about DelivLib is the publishing stage. So we have all these pre-configured actions that you can really easily add into your publishing stage to publish to NPM, to Maven Central, to GitHub releases, PyPI, NuGet. So that's really, really handy. If you've ever published to these package managers, it's a little bit tedious sometimes to integrate and automate the publishing to package managers. DelivLib has that all wrapped up nicely and really easy to use. So even if you're not publishing a construct library, this can be a really great way to publish a Java library, set up a CD pipeline for Java. So just to give you a concrete example, this is the AWS code pipeline. This is our master publishing pipeline for the CDK. This publishes the CDK framework, the AWS Construct Library. We pulled the source code from GitHub, of course. We build with code build. We run a ton of tests to make sure that the releases are ready to go out. And then in publishing, we're using all of those publishing actions that we just talked about. So publishing to GitHub releases and Maven Central and NPM and PyPI and NuGet. So this is, again, all created and managed with the DelivLib project. Another cool project you can go and try out for your construct libraries or any code libraries. Let's check back in IntelliJ. There's one more neat trick I want to show you before we go. We'll let the suspense build for a minute before we check the status dashboard. I wanted to show off this tool for working with JSAI that one of our newest members on the team built, and it is called JSAI Config. So this is a nice little visual tool that you can use to help set the JSAI configuration settings in your project. Alaa, do you know this one?
Yeah, you're in Java.
Oh, I'm in the wrong IDE. Not even close. There we go. So this should work better in VS Code. There we go. Got it. So JSI config has this nice little visual tool that we can use to configure JSI for our projects. You can see the first thing we have to specify is which languages we want to generate for. So we can, maybe we just want to do Java and .NET, play with the new GA languages. And then for each of the languages we select, we're going to walk through some options for how we want to generate the code, where we pull types from, and then a lot of specific information for Java and Maven and .NET and Python. So JSI config, if you are going to play with JSAI, check out JSI config, little bonus tip for you. Okay, so let's go check our status dashboard, and with any luck, we should see our new Java service. Excellent. So we've got our new Java CDK service showing up in US East 1 and US West 2, just like we were trying to use, and we were able to use that TypeScript library that we wrote for our health monitor construct, use JSAI, and really easily use that from our Java application. A couple of final notes. We talked about JSI and JSI PacMac a lot. Really important to understand that those JSI supports a subset of TypeScript, so you need to be aware of those constraints as you're playing with JSAI. DelivLib, I hope you all go and check that out. Super cool library, great way to set up these continuous delivery pipelines for code libraries. And then we kind of scratched the surface a little bit talking about environment-aware applications and how you can encode that environment information into your CDK apps as they get more complex. Okay, I'm going to turn things over to Alaa to wrap us up.
Thank you. OK, that was a lot, I think. But yeah, you can always go back and reverse go back to these slides and see what the details are. We really wanted to kind of inspire you a little bit to see where the CDK can go and things that you can do with it. There's a lot more, and at the end, there's a little hashtag that we wanted you to use if you have ideas for demos and things that you want to see from us. Before we finish, we wanted to give a huge shout out to this evolving ecosystem around the CDK project. It's incredible. We were so humbled by the creativity and amazing work that people are doing, both contributing to the CDK directly, but also releasing these really creative projects that take the CDK to places that we've never even imagined. And so I've been collecting this list called Awesome CDK. If you know of other cool projects, or you're writing a blog post or giving a talk, shoot me an email or a tweet or a PR to this repo, and I'm trying to like catch up. It's becoming hard, actually. So help me. If you haven't already, please take the CDK for a spin. CDKworkshop.com is a good resource to get started. It has a cute tutorial that leads you through your first CDK application, supported in all the programming languages that we officially support. Wax CDK is the CDK homepage at Amazon. You can find the reference documentation and developer guide there. We know documentation is very important. We're really trying. We also know that it's not perfect yet, so please let us know how we can improve. It's also open source. You can also contribute to documentation, but be loud and vocal where things are not good enough. Wax VS Code is where you can get the VS Code extension with the CDK Explorer. And more than anything, we'd love to talk to you. We'd love to hear what you guys are building, how you're doing, where things are working, where things are not working. Please just reach out to us in any channel, right? Like Gitter, GitHub, Twitter, whatever. Knock on our doors. Just come and talk to us. We love that. That hashtag CDK demos is like, if you have ideas or things that you want to see live coding in these types of sessions, we love the ideas. We're kind of running out of ideas at this point. Every time is like a big challenge for us. So let us know. And lastly, last year we had 2 sessions about the CDK at reInvent. This is a partial list, so it's also pretty exciting to see that CDK is helping other various range of areas and fields in the cloud development space. We are also hosting an off reInvent happy hour today with the team. We've got our team come in from all over the world to Vegas. And so please come join us at 5 o'clock at Link. I think it's not going to be at this, it's like going to be next door because apparently this bar is under construction or something like that. So it's like today we've learned. Yeah, thanks so much for coming. We really, really appreciate it. Come talk to us. We're going to hang out here or outside. And see you later.